In fact, if you had the same weight of spider silk and steel, the spider web would be 5 times stronger. Crazy, right? And scientists are just now finding ways to harness the strength and flexibility of this natural material.
What's really neat about a spider's web is that combination of both strength and elasticity and how those work together to stop a speedy insect coming in its web, hitting it just like a bullet would hit a wall. Not only is it strong enough to stop the animal, but it's elastic enough to allow it to slow down its impact.
Look at how thin those strands of spider web are compared to how big the fly is.
If you sit down and do the mathematics, a strand of spider silk as thick as a pencil would stop a 747 jet in midair. That's the kind of dynamic forces we're talking about.
The problem is, you can't just get together a bunch of spiders and harvest their silk.
They're cannibalistic. They eat each other.
If you have a spider farm, you quickly have one spider and a lot of empty jars.
That was before Kim Thompson, founder of Craig Biocraft Laboratories, decided to change the rules of the game. These are silkworms. What if these worms could make silk as strong as a spider web?
My idea was simple. Take the gene sequences from the spider and insert them into the silkworm, and then the silkworm could incorporate those proteins into its silk fiber, reinforcing them and creating a much stronger, more elastic material.
Thompson wanted to cross a spider with a silkworm. Well, the idea might be simple, but it's not easy to do. So Mr. Thompson decided to join forces with Dr. Malcolm Fraser and his team at the University of Notre Dame to accomplish the task. Dr. Fraser, how do you exactly get the genetic information from the spider into the silkworm egg?
And we use a microinjection apparatus that Dr. Son here is using right now. She pokes the embryo to make a hole, and then she puts the DNA from the spider into that same hole, and hopefully some of the embryos have picked up some of that DNA and incorporated it into their own genetic material, and now they will produce spider silk.
What about the success rate? How many of them actually have the spider DNA?
If we're lucky, we can get about 10 out of 500.
Those aren't great odds, but the adult silkworm moths that do have these properties can be bred together to lay eggs that should hatch to create a new generation of spider silkworms. This is where the silkworms actually live, huh?
Yeah, right now, what you're seeing here are all larval stages, and there are 5